Hi, Year 9. So today's big question is, how do we program? Now, this links back obviously to everything that we've done previously in the programming units of work in Year 7 and Year 8. But in Year 7 and Year 8, we've only been using something called block programming. So it's where we've clicked and dragged blocks of code into our coding environment to, give the computer instructions on what it needs to do. And that's all been really good, but it's really low stakes. At no point are we ever really making any mistakes. Today, though, we are going to start learning how to code using Python. Now, Python is a coding language where we are going to have to type our instructions to the computer. And we're about to learn that typing it means that we have to be absolutely exact in the way that we give the computer those instructions. So a quick recap of everything that we've done so far in programming and in algorithms. Remember, an algorithm is just a set of step-by-step instructions that solve a problem. It's not related to computers in any way. It's just a word that is used for anyone or anything that follows a set of instructions to do something, like a recipe or directions to the park or whatever it is. But there are three ways to write an algorithm in computer science. In Year 7, we learned about how to write algorithms as flow diagrams. In Year 8, we learned about how to write algorithms as pseudocode. And this year, we're going to learn about how to write those sets of instructions, but as computer programs, because it's only computer programs that are written for computers. So when we are talking to a computer, the syntax, the way we write it, is really important. It needs to be 100% accurate. Any mistakes lead to something called a syntax error. It's when you break the laws of a language. For example, if you spell something wrong in English, then technically you are causing a syntax error. But unlike your English teacher that will be able to read your work, regardless of whether you've got spelling errors in there or not, a computer cannot continue if it gets an error in your instruction. So it's a mistake in your code. That means the computer can't follow your instructions and make the program work the way you want it to. When you first start to code, which is the journey we're starting today, you're always going to end up with syntax errors. I've been coding for nigh on 20 years, and uh, I still have syntax errors in my code. But the trick is to, number one, not let it get to you, but number two, read your code again. The more you code and the more you practice writing code, the better you get at debugging your code, figuring out if there are any syntax errors before you even run it. But bottom line is, syntax error is no one's fault. The computer's trying to follow your instructions, and you have tried to write those instructions correctly. So it's no one's fault, but it can be as little as if you misspell the word print in that line of code there, where it's print hello, that will accurately output the word hello to the screen. And if you started that line of code with a capital P instead of a lowercase p, the computer will literally turn around to you and say, I do not understand what you're trying to tell me to do. Because we have to be that accurate with our instructions. So syntax aside, another key thing that we're going to learn about in the next, few weeks while we're doing this unit of work is that data is categorized in programming. It's so we can then use it in the right way. In the same way as you'd uh, use a specific tool for a specific job. For example, you wouldn't use a screwdriver to hammer in a nail, or you wouldn't use a spanner to measure a piece of wood. Each tool has a specific purpose, and you would choose the right tool based on the job that you need to do. For example, in programming, we've got two types of numbers. The first type are just whole numbers. They're called integers. We would use integers when we're doing some mathematics or when we're measuring something. It's kind of like a measuring tape where we just need like a whole number measurement of something. But when we need to be a little bit more accurate with our numbers, we use something called floating point numbers. They're just called floats in programming. This is any number that has a decimal point in it. But the one we're going to use the most often is something called a string. A string data type is basically just some text. It can be letters, it can be numbers, it can be symbols. It doesn't matter what it is, as long as it's in a string, Python can show it on the screen. And the last one that we're going to look at, maybe in a few weeks' time, is something called a Boolean data type. Now, Boolean, very much like a switch, can only be on or off, true or false. You know, the computers like ones and zeros. That's basically what this is. Remember, strings are used for text that can include letters, numbers, and symbols. Integers is a whole number. Floating point numbers, or floats, are a number with a decimal point in it. And Booleans are just true or false. In this lesson, we're just going to use text. So we're going to use text like sentences or a word. Remember, they are just strings. One of the most important things to remember from this lesson is that strings are always surrounded by quotation marks or speech marks. So our task today is, well, how do we show strings like hello and goodbye to the screen? We're going to type our instructions in, and that's going to be our input, and our processor is going to process those inputs and show it on our monitors. This is how we accurately tell the computer to output some text. Remember, we have to get that syntax absolutely right. If I were you, I would write down this line of code at the top of your mini whiteboards because we're going to use it quite often in today's lesson. Make sure that you've got print spelled without a capital P at the start of it, that we've got brackets opening and closing, and anything that goes inside of those brackets, all that text, all that numbers, letters, symbols, it doesn't matter what it is, as long as it's within speech marks, then Python will be able to output it to a screen, to your screen. So when this code is run, it will output the string your text goes here. I know it's going to output something because we're using that keyword print, and we know that it's going to output a string because everything inside those brackets are within speech marks. The way we talk about our code is really, really important. It gives us a baseline of how we can then answer those kind of questions in exams later on in a few weeks' time. But it also helps us to talk like computer scientists. So when we are practicing how to describe lines of code, make sure that we're using these keywords and this terminology.